Question 17 on page 117. A sphere of mass 4m travelling with the speed u strikes directly a stationary sphere of mass 2m. The coefficient of restitution is E and prove the speeds after impact R. So the coefficient of restitution is E. So again, X, Y, this is the after, this is the before, and this is travelling with a speed U. It strikes a stationary one, so that's got a speed of 0. Okay. Right, so principle of conservation of momentum. Momentum before equals momentum after. It's 4m times U plus 2m times 0. That's mass times velocity before is equal to mass times velocity afterwards. 4mx plus 2my. Okay, we can divide by m and we get 4u is equal to 4x plus 2y, or we could divide by 2 and say 2u equals 2x plus y. Okay, so there's one equation. Now we have Newton's experimental law. I'll put that up here actually. Newton's experimental law is the difference in velocity afterwards is equal to minus e times the difference in velocity beforehand. So x minus y is equal to minus EU, and that's your second equation. So we have 2x plus y is equal to 2u from down here. So if we add these, we will get 3x is equal to, and we're adding these, so we're going to get 2u minus EU. 3x is equal to u into 2 minus e. Divide by 3, x is u over 3 times 2 minus e. I guess we better just check that's right. U over 3, yeah. Okay, now rather than subbing that back in here to find y, it's a heck of a lot easier to just take the two simultaneous equations again and this time eliminate x and find y. So if we take the two equations again and we want to eliminate x, if we multiply the top one by minus 2, we get minus 2x plus 2y is equal to plus 2eu. Okay, now if we add to that 2x plus y equals 2u, when we add them, our x's add to 0. 3y is equal to 2eu plus 2u, or 3y is equal to 2u times e plus 1, 2u plus 2, and y is then 2u times e plus 1 over 3. Okay, so there are two values. Okay, so the next bit is to find the loss in kinetic energy. So the loss in kinetic energy, I can rub all this out now and we can put in our values. Oops, actually I should have left that one in. That was going at u and that was going at 0. Our x and our y's we can put in now. Our x was u over 3 times 2 minus e, and our y was 2u over 3 times e plus 1. Okay, so the loss in kinetic energy is just the kinetic energy the kinetic energy afterwards minus the kinetic energy before. Okay, it's important to note there's a loss in kinetic energy. Energy is lost in the collision. Momentum is conserved, but energy is lost. Sound, heat in the collision. That takes away some of the energy. Okay, so the kinetic energy before is a half m u squared plus the kinetic energy of this one. It's not moving, so the kinetic energy is 0. Just put it in anyway. Minus, and you're subtracting now, the kinetic energy afterwards. So the kinetic energy afterwards is a half times 4m again times u over 3 times 2 minus e squared plus a half times 2m times 2u times e plus 1 squared. So this is a very good exercise for maths again, for your algebra. Okay, so let's have a look at that. A half multiplied by 4m is 2m. So 2m u squared plus 0, so that's just 0, minus, this is our kinetic energy lost, is going to be, right, half of 4m is 2m, times, now a number squared is the number multiplied by itself, okay, plus a half of 2m is m, and again times the number times itself. Okay, if you like, you can put them in brackets because you know you're multiplying them. It doesn't really matter. Okay. Sorry, there's an over 3 in here. Okay. So that is m times over 3 and over 3. Okay, so what do we get? 2mu squared is the energy, the kinetic energy beforehand, and the kinetic energy afterwards we're going to subtract out now is this bit here. So we have 2 by m. Now, u by u is u squared times 2 minus e by 2 minus e. So 2 minus e by 2 minus e is 4 minus 4e plus e squared, multiply it out, and that's over 3 by 3, which is 9, plus m. Now 2u by 2u is 4u squared, and e plus 1 by e plus 1 is e squared plus 2e plus 1. Okay, over 9. 3 by 3. All right. Now, I'll rub this bit out. Okay, we can go up the top now. Okay. Okay, so now we have 2mu squared minus, no, they're both over 9, so we can just multiply everything out if you like. So you get 8mu squared, that by that, minus 8emu squared, plus 2mu squared, plus 4mu squared by e squared, plus 4mu squared by 2e, which is 8mu squared e, I think, plus 4mu squared. 4mu squared by 1. And that's all over 9. So let's tidy the top bit. So that is 2mu squared minus 8mu squared plus 4mu squared. That's 12mu squared. Minus 8emu squared. There's another emu squared. Is that right? 8emu squared. That should be a squared. Just looking at it here. Should be a 2mu squared by e squared. Okay. So that's an emu squared, and we have minus 8. We have emu squared, and we have plus 8, so they're going to add to 0. We have 2me squared u squared, and 4me squared u squared, so that's 6me squared u squared over 9. So now if we want to take away two fractions, or take away a fraction, we should put this one over 9. So multiply it by 9 on the top, on the bottom, so we're not actually changing it. So that's 18mu squared over 9. Take away 12mu u squared plus 6m e squared u squared over 9, which then gives you 18m u squared minus 12m u squared. Remember, you are taking away all of that, so you're taking away the 12m u squared and you're taking away the 6m e squared u squared all over 9, which is 6m u squared minus 6m e squared u squared over 9, which we can factor out. That's 6m u squared into 1 minus e squared, 6mu, yeah, over 9, and then we can divide the 6 by 3 to get 2 and the 9 by 3 to get 3. So I think the answer is 2 times 1 minus e squared over 3. Good exercise in maths. That stuff comes up in the applied